Think math.
Toss a coin and keep a running record of the proportion of heads. 10 tosses gave 7 heads, so the proportion is not 0.7, rather lopsided. But stretch it to 100 tosses, then 1,000, and the number creeps towards not 0.5. What is pulling it there? The secret is how much one toss weighs. 10 tosses in, one more toss can shift the proportion by about 1/10. That is a lot of leverage. 1,000 tosses in, one more toss can shift it by barely 1,000th. The same single toss with 100th of the power. So the number grows calmer. Early on, it jumps about with every toss, but as the count builds, the jumps shrink and the graph flattens out. Once the jumps are small, the value has nowhere to go but to settle. And when you actually run it, it settles at the same place every time. The name we give that value is the probability. Not 0.5 for a coin, 1/6 for a given face of a die. Not a value we decided in advance by calculation, but one that came from watching where the proportion gathered. That is why it is also called experimental probability. It is the value the experiment reported. One thing must be said plainly. This value does not predict the next toss. 5 heads in a row does not mean tails is due. A coin has no memory of the last 5. What calms down is the overall proportion, not the next single toss. So as trials pile up, a single result loses its power to move the whole. The proportion wobbles less and less, settles on a value, and that value is what we call the probability. Next time, choosing a single number to stand for a whole data set. See you in the next one. A sip of math every day here at Think Math.